All right, pre-cal, in this video, we are going to be looking at Unit 8, solving triangles. So in our very first video, we're going to be talking about Topic 1, right triangle applications and bearings. How very exciting. Okay, so we're going to go ahead and start. You'll notice that all of these are right triangles. That's because we're going to use right triangle applications. So we are going to use SOHCAHTOA that we already learned. So remember that means sine of a degree equals opposite side over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So let's get started with number 1. We've got to find the value of x and we've got to find the value of y. So in relation to 16 degrees, y is the opposite. This is the hypotenuse, and this is the adjacent. So you can start with sine or cosine, it really doesn't matter. But the sine of 16 equals the opposite over hypotenuse. And I'm going to treat this as over 1 and then cross multiply. So that's what I get there. And then I'm going to round this side measure since y is a side measure. But I need my calculator to find 9 of sine 16. So I'm just going to open up Desmos and I'm going to use sine. Oops, I forgot my 9. So I've got 9 times the sine of 16. So that gives me 2.48, blah, blah, blah. We are going to round these to 1 decimal, so I'm just going to round that to 2.5. So y is approximately 2.5 centimeters. Okay, so now we're going to use cosine, and we are going to find x. So the cosine of 16 degrees equals adjacent over hypotenuse. So we are going to cross multiply again. So think of that as over 1. X equals 9 times the cosine of 16. So x is going to be approximately, and let me get Desmos out again. That's going to be 9 times the cosine of 16. So that gives me 8.65 or 8.7. Easy peasy lemon squeezy. All right, let's get to the next ones. Now on these, we are told to solve the triangle. So that means we're going to find everything that's missing. So we're going to use SOHCAHTOA, one of those, to find x, and then we can use the triangle sum theorem to find this angle, and we can use the Pythagorean theorem to find this side right here. So we're going to start with x, and 38 is opposite it, and that's the hypotenuse, so we're going to use the sine of x. So the sine of x is equal to opposite over hypotenuse. Now for these problems, we don't have the angle measure, so we have to use sine inverse. So in the calculator or Desmos, we're going to type in sine inverse of 38 divided by 42 to discover what we get for x. So I'm going to go back to my calculator, and if you'll go to this function button, you can find sine inverse. So I'm going to use sine inverse of 38 divided by 42. And that gives me 64.79. I'm going to round my angle measures to a whole degree. So I'm just going to write 65 degrees down. So x is approximately 65 degrees. And now I can find this angle. And the way I can do that, I'm just going to call that angle R. So R is going to equal 180 degrees minus 90, that's this angle, plus 65, because we know that a triangle has 180 degrees total. So I am just going to use my calculator again. So I've got 180 minus 90 plus 65. I use parentheses. It's important that you do that. So that other angle is 25 degrees. Oh, dang it. Okay, so 25 degrees for angle R. And now we're going to use the Pythagorean theorem. I'm going to call this little a. So a squared plus 38 squared equals 42 squared. So A is going to equal the square root of 42 squared minus 38 squared. Did I say minus 38 squared? I think that's what I said. Okay, so you get 17.9. Oh, it's approximately. Did I say 17.9? I swear, I'm out of control today. I know what you're thinking today. All right, so now we're going to do the same thing with number 3. So we've got x right here. We're going to use, this is the adjacent side, this is hypotenuse, so cosine x equals adjacent over hypotenuse. So I've got cosine inverse of 13 divided by 18. And we get 43.7, or yeah, 43.8. But that's a degree measure, so I'm just going to round it to 44. All right, and to get our other angle, let's call this angle S. Angle S is equal to 180 minus 90 plus 44. And we get 46 degrees. And now we're going to, oh, I didn't put boxes around all my values. Sorry, kids. Okay, and now we're going to use the Pythagorean theorem again. I'm going to call this little b. So b squared equals 13 squared, oh, sorry, plus 13 squared equals 18 squared. So b is going to equal the square root of 18 squared minus 13 squared. And that's going to give me 12.4. So b is equal to 12.4 approximately meters. Awesome. I hope you've enjoyed this video. Oh, you know what? I better look at Paul first. Okay, so let's look at Paul. All right, he wants to determine the height of a tree. He looks up to the top of a tree at an angle of 45 degrees. So that's going to be 45 degrees. If he is 6 yards from the tree, so that's 6 yards. And his eyes are 5 feet from the ground, so that's going to be 5 feet right here. Find the height of the tree. So we need this portion right here of a right triangle. Now, I did not draw this to scale, but if this angle is 45, then this angle is 45, and that means these are congruent. So that means that from here to here is 6 yards. So the tree's height is equal to 6 yards plus 5 feet. So I am going to transform 6 yards into feet. There are 3 feet in 1 yard, so 3 times 6 is 18. So that means the height of the tree is equal to 23 feet. Easy peasy, lemon squeezy.